1.2, which is talking about functions. So we're going to talk about domains. Okay. So before we talk about domains, I want to talk about what's called an implied domain. That's a weird looking word, isn't it? An implied domain. No, yeah, pretty good. There is
What are you trying to write?
Okay, I don't remember. All right, so implied domain. But it didn't say it was an S, so whatever. All right, so implied domain. What does the word implied mean? Okay, so you should know it without, that's right, without
So you're about to tell it.
him saying it. Okay? So, for instance, if I'm talking about this formula, A equals pi r squared. Okay? What's that the formula for? The area of a circle. Okay? The area of a circle. Y'all listen to me. Is this the graph of a circle? No, it's not. Okay? It's the area of a circle. Is it a function? Is A a function of R? Yes, it is. Okay? What if I ask you about its domain? Which one is its domain?
R.
Very good. So the domain would be any R such that what? What?
R equals 30.
What can R be? Any real number? Yeah. Y'all listen to me. What does R stand for? A radius. Okay? What does R have to be? Greater than 0. That's an implied domain. Okay? There are no restrictions on this equation. Okay? And we're just going to talk about the restrictions and stuff, but there are no restrictions on this equation. But there's an implied domain. R has to be greater than 0. If it's not greater than 0, I mean, what kind of circle has a radius of -4? Yeah, that's just wrong. You can't have that. So that's what it's talking about an implied domain. An implied domain would be something like that. Okay? That maybe was a real life problem. That's right. If you're dealing with money, if you're dealing with time, things like that. Okay? All right. So let's do this. Let's talk about domain. All right. So tell me what the domain is. The x value. You could also call it the input, and you could also call it the independent. Remember this? Variable. Okay? The independent variable. Now, listen to me. The domain is going to be all real numbers. Okay? Let me say it this way. Right now, when I say domain, what's the first thing that comes into your mind? Okay. From now on, when I say domain, the very first thing I want to come in your mind is this. Restriction. Okay? Now, we did this last year. Do you remember? Okay. So, when I say domain, you need to go, are there any restrictions? How many restrictions do we have? You got to remember 2. Very good. 2 of them. Now we get that. 2 restrictions. Anybody remember what one of them are? What are some things that create problems if an X is where? An X in the denominator. Why is that going to create a problem? It can't be 0. If you have an X in the denominator, you have a restriction. Whatever makes that 0, you can't have that x, because division by 0 is undefined. Okay? So, here's what you do. Okay? You set the denominator. That's okay.
I didn't pick up the
You set the denominator equal to 0, and you solve for x. And then what are you going to do with that number? You're going to exclude that number from the domain. Why? It is a real number. It creates a 0 in the denominator, and so it makes your function undefined at that point. Exclude that number from the domain. Yes, we can do interval or set notation. We're probably going to do interval notation. Yes. All right. Anybody know the second one? What's that do? Why? What are we talking about? Oh, Jessica said this has something to do with the radical. No, that's rationalizing something. That's right. If you have an x under the radical. Now, why is that? Why is that a problem? That's exactly right. The square root of negative numbers, we can take them, okay? We are smart enough to take them, but they are imaginary or complex numbers, okay? So, I don't think I need this A right here, do y'all? We'll just say, what do you do if you have an x under the radical? Okay? Here's what you do. You take what's under the radical, and you say you must be greater than or equal to 0. It has to be greater than or equal to 0 in order for us to be able to get a real answer. Okay? And then you'll solve for x, not solve the cost. Solve for x, and that is your domain. Okay? Alright, so here's the rules, guys. I'm going to say, what's the domain? What is the first thing you're going to think? Restrictions. How many restrictions do we have? 2 restrictions, okay? So I'm going to give you an equation, and I'm going to say, what's the domain of this equation? And you're going to go, oh, does it have any restrictions? You're looking for an x in the denominator or an x under the radical, okay? If it doesn't have an x in the denominator or an x under the radical, what's its domain? That's exactly right. Negative infinity to positive infinity, unless it's a real-life problem, okay? Not just an equation, but an equation that's attached to a real-life problem, and then it could have an implied domain, okay? All right, so you ready? All right, so you keep those little notes handy. Find the domain. All right? Find the domain. Here's the first one. If you miss this one, y'all get the course with. Okay, we're going to write this domain in proper set notation. this. Proper set notation. Exactly right. It's in braces because it's a set. Okay? And it starts out, we talk about the domain, so it's any what? X. How do you say such that? It's a line. You could also put a colon right there. Okay? Different books will do it different ways. Different teachers have different ways. But a line or a colon, either one of them means such that. Any X such that X is equal to what? -3, -1, 0, 2, and 4. Very good. What if one of them repeated? Would I write it twice? No, you would not. Do they have to be in some kind of order? No, they do not. Typically, it's kind and considerate to put them in like some type of order, all right? So you don't have to look all over the place for them. Yeah, but they don't have to be in any kind of order, all right? All right, everybody okay? Here's the next one. -3x squared plus 4x plus 5. Don't say it, just write it down. You find it. You don't have to use that. I'll put it in both of them. Let's do it in both, okay? This one you can't really write in interval notation because it's, what's that called? What's that function called? No, we talked about it yesterday. Didn't we talk about that? No, we didn't. Okay. I thought we talked about that. When we grabbed the one and we asked if it was a function, we did the vertical line test. We did that? What? We didn't do that? No. Did we do it the day before? No. Okay.
We stopped at this. We know what that is.
Okay.
We stopped at this. You never said
Oh,
that.
but you said, I think we were about to do it. Oh, okay. Well, that was skipped right over it. All right, I'll go back and do it. Okay, domain. This is a discrete function. It's just a bunch of points. It's not connected. Broken, is what we say about a discrete function. All right, does anybody know what his domain is? Why? Yeah, y'all listen, don't miss one like this, okay? Remember what I said, as soon as I say domain, what's your brain supposed to think? Restrictions. Does he have any restrictions? There's no restrictions. People, there's not even a fraction or a radical in it, okay? So, he has no restrictions. What's your domain? Negative infinity to positive infinity, okay? Now, what if we wanted to write it in set notation? Any x such that, that's it. X is an element, remember, that's a C with a bar in it, of the real numbers, which is a double-barred R. Alright? X is an element of R. Y'all, you need to know both of them. I think on the worksheet it asks you for both of them. Okay? Friday. Y'all may get it tomorrow. If we get finished with our stuff tomorrow, I'll give it to you tomorrow. The other classes won't probably get theirs until Friday. Okay? Alright, so here we go. Here's the next one. You ready? I lost my place. Yeah, I'm sure you'll get right on it.
You have time to work on this.
You said you're working on it in class. That's it. Alright, H of x is equal to 1 over x plus 5. Tell me what his domain is. Tell me what his domain is. Follow the rules. You got the rules written down there on your paper. And looks like this. And looks like that. Alright, y'all got it?
Yeah.
Okay, so, I asked for the domain, what's the first thing you're supposed to think? Restriction. Does it have any restrictions? Yeah. What is its restriction? It has an X in the denominator. So what did your notes tell you to do? Alright, so set the denominator equal to 0, and then solve for X. So we subtract 5 from both sides, and X is equal to -5. Now, what am I going to do with that? I'm going to exclude it, okay? I'm going to exclude it. So, in interval notation, that means X can be anything in the world except -5. So I'm going to go from what? To -5. And then I'm going to exclude it. Remember interval notation, a parenthesis means excluded and a bracket means included. Union, -5 to positive infinity. Okay? Yes? The parentheses means excluded? Yes. Remember, a bracket looks like he's holding his little arms out, trying to include you. No, this means included,
I didn't think about that.
and this means excluded. Okay? What? Alright, what about set notation? What's it going to look like? I'm going to write it this way. Okay, I wouldn't count that wrong. Okay? But watch. When it's just like one number like that, can I do this? X is an element of R, comma, X cannot be -5. Okay? Alright, you ready for another one? Here's the next one.
So you put the comma and the comma like.
Yeah. Oh, we're fixing to get up from learning here. There you go. Tell me about your domain. Alright, y'all got it? So, tell me about its domain. What are you thinking? Restrictions. Does it have any restrictions? Why? It has an X under the radical. Okay? Now y'all listen to me. Just because it has a radical in the problem, does that mean it has a restriction? No, only if it has an X under the radical. So, what did it tell you to do? Under the radical, and you say you have to be greater than or equal to 0. Now we're going to solve for X. So we're going to subtract 4 from both sides. Negative 3x is greater than or equal to negative 4. Now what am I going to do? And ding, 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 ding. Everybody agree? Every bell and whistle in your head ought to be going off. Why? Very good. When you divide by a negative, you have to flip the sign. Okay? So, what's negative 4 over negative 3? Positive 4/3. So, x must be less than or equal to a positive 4/3. Okay? So, integral notation, what does that look like? Negative infinity to 4/3. Inclusive or exclusive? Inclusive. Very good. Okay? In set notation, it looks like this. Any x such that x is less than or equal to 4/3. Got that one wrong? Yeah. All right. What about this one? Alright, everybody got it?
Yep.
What's my domain?
0.
Very good. Y'all, this has an implied domain. If you look at this right here, you go, he doesn't have any restrictions. You see what I'm saying? But that's that implied domain. His domain is going to be in integral notation from 0 to positive infinity. Alright? In set notation, it would be any r such that r is greater than 0. Alright, you want me to try to give you a tricky one? Okay. So glad you want one. Alright. They're doing something wrong together. More of the problem. Because I'm sure it would go a long way.
I'm gonna get Anna if you want.
All right, y'all ready? Zach, I'm guessing you're ready. Okay? All right. So, tell me what you got here. Any X, that's that, what?
Yep, that one, right there. Yep.
What, did you work it? You were looking at your phone. Did you work the problem?
No, I didn't.
Oh, give me a break. Okay, so if it has an X under the radical, what did the rule say? That is greater than or equal to 0. Okay? But, yeah, but we got another problem too. Okay? You can't have equal to 0 because that creates a 0 in the denominator. So I can just take that off. Does that address both of them? Okay. So then you go 2x is greater than -6, x is greater than -3. So there's my domain. Any x such that x is greater than -3. And in interval notation, it's going to go from -3, non-inclusive, okay, because you can't have 0 down there, all the way up to infinity. All right? Now, would that look different if I put another x, if I put the radical on the top?
Yeah.
And an
It
x
would be
down
greater
here?
than,
You got to take both of them into consideration. What if I, would you have to do both of them? Watch what's going to happen, guys.
But you said the x, you said it to 0.
Okay,
It should be 0.
that's right. So, but watch this. 2x plus 1 has to be greater than or equal to 0. Y'all agree with that? So 2x greater than or equal to -1, divide by 2, and x has to be greater than or equal to -1/2. But, what else do you know? X cannot be equal to 0. So look what that's going to look like, guys. If you look at it on the number line, it might be more sensitive. Here's 0, here's -1, here's -1/2. It starts here, right? Is it included? Yes. Yes. And greater than goes where? To the right. But I got to exclude that little 0 right there. So, what's it going to look like in interval notation? From -1/2, what? Inclusive or exclusive? Inclusive. So what? 0, exclusive, union, 0, exclusive, all the way to positive infinity. Okay? Alright, very good. We got 5 minutes. Let's talk about this one for a second, and let's see who could do it. Okay? This is example 6. Okay, this is Chapter 4, Section 9 in your Algebra 2 book. Chapter 4, Section 9 in your Algebra 2 book. Okay? So, Chapter 4, a whole bunch of you went, oh yeah, I'm pretty sure I don't remember that. Okay? So, guys, listen to me. I taught this to you last year, but I'm going to teach it to you again. Okay? Really important. Now, there is, well, we're going to teach it today, and then we're going to go back and do it again tomorrow. Okay? So I'll give you 2 days. All right. So, everybody knows, do I have any restrictions? So, I have an x under the radical, so here's what has to happen. This has to be greater than or equal to 0. Okay? Now, here's the way you solve it. See who remembers how to solve a quadratic inequality. The first thing you want to know, really, y'all, we're going to cheat with a picture. That's essentially what I tell y'all to do. Okay? So I'm going to try and find my zeros, my x-intercept. So we're going to factor it. X and X. Plus sign at the end means what? They're both alike and they're like the first one, so minus and minus. What are the factors of 2 that add to be 3? 1 and 2. So if this is my factor, what's my root? If this is my factor, what's my root? Okay, so think about what you have. You've got a parabola and it intersects. Y'all, do I care about the y-axis? Look, do you see any y? Okay, I don't care about the y-axis. Okay? It intersects the x-axis at 1 and at 2. Here's the other important part. Does it open up or down? It's positive. It's a positive x squared, so he opens up. Okay? So he does like this. Now, look at what this thing's asking you. I want the part of this parabola that is greater than 0. Y'all, this is 0 right here. Okay? So, if it's a hump or the tail? Very good. Y'all remember us doing this last year? Okay. So, you just draw your little parabola, find your x-intercept, and then say, what part of the parabola do I want? If you want the parabola that's greater than, and it opens up, then you want these tails. These are my solutions. Okay? Now, where are the x's that give me those solutions? Are they outside or inside? Outside. So y'all, here are your answers. Okay? The x can be 4. Now, are these going to be solid dots or hollow dots right here? Very good. So we're equal to right there? That makes them solid. So my domain. So let's do this. Let's do the interval first. From what? Negative infinity to what? 1 union. Oh, sorry. Yes, you're right. Equal. Union with what? 2 positive infinity. Very good. If you wrote it in set notation, it would be any x such that, y'all listen to me, always write the left one first. It just makes sense. We read from left to right. Such that x is less than or equal to 1, or, and you can put the word or a union symbol in a set. I always use the union symbol because you can't use the word or in the interval notation. X is greater than or equal to 2. On the worksheet, I think it asks you to do both, because the test might ask you one way or another, so you need to be able to do both. Okay? Very good.